Here we go. Okay. So we have some terminology here. Okay, that's important to know. When you're actually solving it, though, this won't really come up when we solve it graphically. I mean, the terminology here still applies, but the next two statements here, they only really apply when we're solving it by substitution or the elimination method. Namely, if when you're trying to solve it, you get a false statement, something like 0 equals k, where k is a non-zero number, or you can get something like 1 equals 2, something, a false statement like that doesn't contain any variables. That tells you there are no solutions. So if when you're trying to solve it, you get something that doesn't make sense, like 0 equals a non-zero number, like 0 equals 1, or 1 equals 2, or 5 equals 8, or something like then there are no solutions. Or like 5 equals 10, there would be no solution. If, however, you get something like this, which is true, and there are no variables, like 0 equals 0, 1 equals 1, in that case, there are infinitely many solutions. So in the first statement, we get a system that's inconsistent. In the second statement here, the system is consistent, and the equations actually are dependent because there's infinitely many. I mean, what's nice about that, though, is if you find more than one solution when solving it, then there has to be infinitely many. Or if you get something like this. Okay, that's good. Well, let's try some examples. Let's actually solve this system. We found a solution, but let's actually solve it to see if there are any others. And I'm going to use substitution. And just like with when we were dealing with quadratic equations and solving those, remember how we could use factoring or the quadratic formula? If I tell you to use a method, you have to use that method. But if I don't tell you, if I just say solve the system, then you can use any method you want. But here I'm going to solve it using substitution. Okay, so I'm going to take the first equation, right, as you can see, and I'm going to get one variable in terms of the other. So I'm either going to get x in terms of y or y in terms of x. What I'm going to do here is get y in terms of x. Now you might be thinking, why is he doing that? Well, because notice the coefficient of y is a negative one. We're subtracting. If the coefficient is 1 or negative 1, then I would get that variable in terms of the other. That would be my first attempt. So I'm going to do that here. So we have 2x minus y is 5. Okay, so, just algebraically, I'm getting y in terms of x. I subtract 2 times x from each side. We have minus y is 5 minus 2x, as you can see. Okay, but we don't want y. We don't want minus y. We really want y. So, we can multiply or divide actually by negative 1. I'm just dividing by negative 1. So I get y equals this. And so from here, we get y is negative 5 plus 2x, which is the same as saying y is 2x minus 5. So that's what we get here. So we have y in terms of x now. Are we done? Well, not quite. What we can do next is plug this into the other equation, the one we didn't use. You don't want to plug it back into this equation. That's not going to get you anywhere. You want to use the other equation, and that's what I'm doing. So I'm substituting into the second equation, as you can see. So from here, we get x plus 2y. This isn't wrong, but I just want to fix something. I just want to, oh, wait, never mind. Okay. I thought something was wrong there, but I'm right. So we get x plus 2y, right? We're plugging into the second equation, is x plus 2 times 2x minus 5. Again, y, from the first equation, we get y is 2x minus 5. So we're using that here. And this whole thing is 5. But how does that help us? Well, notice now, if you look at this, if you look at just this part here, which is also down here, I really now have only one equation with one variable. I only really have just one variable. So in a sense, we killed off the y variable. And this kind of equation we can solve. This is from section 1.1. What do? We isolate x, right? So from here, we can distribute 2, which is what I'm doing here. I'm showing all the steps. So we get x plus 2 times 2x minus 2 times 5. This is 5. And so this is 4x minus 10. And now this becomes 5x, combining like terms, minus 10 is 5. So you can see that with the substitution method, we essentially eliminated a variable. And we're now in the situation of 1.1. We have an equation and one variable. Let's solve. So we're solving for x. So, as before, we're just going to get x all alone. So we add 10 to each side. We get 5x is 15. But we don't want 5x, we want x. So what do? We divide to get x equals 3. So we got x equals 3. Okay, that's awesome. Are we done? Almost. We need y, the y variable, right? I mean, once you know what x is, we're good, because we know what y is in terms of x, right? We have y equals 2 times 3 minus 5. But we know what x is, right? So we get 2 times 3 minus 5, which is 1. 6 minus 5 is 1. So the only solution is 3, 1. So that solution we found, 3, 1, it's a unique solution. Thus, this is a consistent system, and these equations are independent. I mean, I wrote this as the solution set. I don't remember if Lumen has you do this or not. I honestly don't. But again, just in case, you use curly braces. Okay. But we solved this system. Okay. Are there any questions on this? Okay. But basically, I just demonstrated what the substitution method was, okay? So what we did was we used an equation to get one variable in terms of the other, right? That's really what we did. We got one variable in terms of the other, and then we substituted into the other equation, right? We got, for instance, that's what we did here, right? We got y in terms of x, one variable in terms of the other, okay? Then, okay, the next thing we did was we plugged that into the other equation, right? That expression we got y in terms of x or x in terms of y. We plugged that into the other equation. And by doing that, we got an equation in one variable. Okay. right? So we solved it. We solved that equation. The value we got, right? In this case, we got an equation in only x. The value we got for x, right? What we did was we plugged it into the expression from step 1, it looks like. Excuse me, in step 2. I'm sorry, step 2. I keep pressing the wrong button. In step 2. And then we just check by substituting. So once we get that equation in one variable, right, like we did over here, we solved it. The expression we got for one variable in terms of the other, as you can see, right, which was step 2. No, excuse me, not step 2, step 1. That should be the first step. We just check by substituting. Right, so once we got one variable in terms of the other, y in terms of x, then we plugged what we got for 3, we plugged that in, and then that gives us the other variable. It's just like what we did over here. I hope it's making sense what I'm saying, but it's just like what we did over here, that's all. So this is what I was trying to say. I was trying to illustrate the substitution method here, so that's all. Yeah, let me pause this.